Okay, here we go. We are going to go through characteristics of a couple quadratic functions, and first we're going to graph these functions. So if you have a function like this one is written in standard form, which is not a great form for graphing. It is a great form if you want to just put it in your calculator and you can take off some points from that. The other option would be something like completing the square with this, which would involve dividing everything by -4, and just a whole, you can hopefully remember some of the completing the square process, if not the whole thing, and that's what you'd have to do. The other option, you could take a number like -2 and plug it in here. So -4 times -2 squared minus 32 times -2 minus 63. And you're going to need a calculator for that probably. So that would be -16 so that would be 48 minus 13 would be -15, and that would be 1 point. Equals what? Equals -15. So -15 would be the y, that would be the x, okay? That's a pain. So what you're going to do is you're going to get your calculator. You'll hit the y equals button, so your calculator comes on, hit the y equals button at the top left. Let's move this down a little bit. And you just enter in the equation. Oops. So you start with the negative button down here. For the x is right next to the alpha key. And then you can hit this little button right here, x squared. I don't want to do that. And then minus 32x, all that. And you hit graph. Oh, there it is. Cool. If you hit second and then graph again, it will take you to a table. And in that table, you see that 1 point I mentioned, -2, -15. And you can start plotting those points and just kind of plot the ones that will fit on the graph that you have provided. So the next point would be -3, 3, -3, which would be right there. -4, 1 is also a point. That's the vertex. -5, -3. And -6, -15. And so the function, something like that. Trying on this thing is so hard. Okay. So in short, if it's not already written in vertex form and very easy to graph by hand, I would suggest graphing it with your calculator and using it to find some points for you to put on your graph. Okay. And the calculator can do other things for you. We'll just do some of the stuff that we can just by observation, and then we'll go back to the calculator to do a couple other things. The first one is domain and range. And domain is just the possible range of x values. So what could I plug in here and here and get something out for y? Basically that won't cause something to be undefined, or no square roots of negatives, things like that. And what you would see if you were to zoom out. So let's go back to the graph. I'm going to zoom, hit 3. I'm going to go over here. Zoom out. There's my function. Hit zoom. Zoom out. There's my function. And this thing, although it's going to be very skinny, it will keep going out. So if we look at the table, you just keep going, and you see these numbers, the y values keep getting bigger and bigger and bigger, but they're there for every single x value. The domain is from -infinity to +infinity. So what is the range? The range is the possible x values that I could have. When you look at these arrows down here, where do these arrows point? They point downward. And in the y direction, down is where -infinity is. Again, if we go down to our graphing calculator and look at the y values, that is a big negative number, and as my x's get bigger, the y values are just bigger and bigger and bigger negative numbers. So that means my range, there is no lowest value, but there is a highest value. Look, it's like the peak of a basketball shot or something like that. It never gets above this point where the y value is 1. But there is a y value of 1, and that's why I include this bracket here to show 1 is included, but anything over 1, 1.0001, not a part of the range. We put a parenthesis over here, and with our infinities, we always use parentheses because you can't reach infinity. So you can't really include it, say that this is still going. Okay, now let's do part B, which is where is this function increasing? On what intervals is it increasing? And on what interval is it decreasing? All right, increasing and decreasing is about your height on the graph. How is the graph going up or down? That tells us increasing or decreasing. The interval, that's your x's, is going to tell you when that happens. When is the function increasing? When is the function decreasing? And those both are going to be x values. So I'd come over to the graph and I would draw some arrows up and down. Because we start on the left and we imagine that if we were in a little go-kart riding on this function, we would be going up first, which is increasing, and then we get to this point up here and we'd come down. Our height would be decreasing. Okay? So increasing, when does it start? When does it start increasing? Well, it comes from negative infinity, so it's been increasing since the beginning of the domain. So what's the first x value? Negative infinity, and you can get that from your domain. That's where my first interval should start, at negative infinity. And it's increasing, increasing, increasing. As we come in from the left, the height is getting bigger and bigger and bigger until we get to this point. So when the y value, the highest y value we ever get to is 1, but when does that happen? That's the number that goes in this blank. It happens when x is -4. There's your first interval. Both of these are x values. Like the number of pages in a book, we are thinking about what page or when is this happening. Okay, and then it starts to decrease. So that same number at -4, it's not increasing or decreasing. It's in that middle moment, the moment between them. Stopped increasing, started decreasing at -4, and then it's going to decrease for the remainder of the graph. If you go further to the right, the y values that you get will get lower and lower and lower. Okay, for part C, I'm going to do that by hand first, and then look at the calculator. Part C asks for the x and y intercepts, I think. Let me double check that. Yeah, x and y intercepts. Well, let's do the y-intercept first because it's the easiest. Y equals -4x squared minus 32x minus 63. That's the equation. What is true of the y-intercept? We know either x or y. Which one of those do we know at the y-intercept? So when the function crosses this line, we don't know where it is at this point. That's what we want to know. That would be the y value. But we know the x value. That's where x is 0. So in the equation, you just plug in zeros for all the x's. And you get -63. Holy cow, that's just the constant term. Is that always the case? Yes. So the y-intercept is 0, -63. And what are the x-intercepts? I'm so glad you asked. Let's find the x-intercepts. Another way of talking about x-intercepts is to say zeros. How do we find zeros? We can do it with completing the square. We can do it with factoring. This thing will factor, and we could do it with quadratic formula. I want to see if this thing will factor. So that's 126, that's 252. So what I'm doing here, and I'm just showing that this can be done by hand. Taking that -4, multiplying it by -63, and you get 252. And are there factors of 252 that add up to -32? The middle number? Yes, there are. But how could you find them if you didn't just know them? Again, you can use your calculator. 252 divided by x. So the number you want to be factored divided by x, you hit second and graph. And every single line or every single row in these columns represents factors of 252. And -18 and -14 add up to -18, -14. -18 times -14 is 252. -18 plus -14 is -32. And so we can factor this as x minus 18 divided by x minus 14, but wait, we still have to divide both of these by a, whatever number we multiplied by. And we're going to simplify this fraction to 9 over 2. We're going to simplify this fraction to 7 over 2. And then we'll do the old bottoms up method. We get 2x plus 9 times 2x plus 7. Set those equal to 0. Okay, so if we were trying to find the x-intercepts, we would set y equal to 0. But that's a very difficult thing to do when you have an x and an x squared. We have to have some special method. And in this case, we can use the method of factoring. So now we've got them down to linear pairs, and we just set each one of those linear pairs equal to 0. X equals -9 over 2, which is -4.5. X equals -3.5. And so my x-intercepts, finally, are -3.50 and -4.50. Does that look right? 3.5, 4.5? I'll be. It does. Okay, that's long. So now let's show the easier way, which would be to use your calculator. Go back here. You want to type this equation in, -4x squared minus 32x minus 63. There it is. I want to, if your window's ever messed up, hit zoom and 6. All right, I want to find these two things. Those are called zeros, right? If you hit second and trace, you can go down to number 2, which is 0. And second trace tells you a lot of good things, so remember that. And hit enter. And it's going to tell you left bound, and it's going to give you x and a y down here. The x and the y down there are the location of your cursor. So it's way down there. We want to get it over here to the left, which is the negative direction. There it is. And what do we want to do? Well, we want to find these zeros. So I'm going to find this one first. See where the cursor is blinking? I want to know that 0. This isn't it. It's close, but it's not it. So what you have to do is put your cursor on the 0 that you want, and see how it says left bound? You need to go to the left. 1 or 2, really 1 is fine, but move it to the left a couple and hit enter. And then it's going to say right bound, and you move it to the right. You got to move it past that 0. Doesn't matter how far, as long as you don't pass the other 0. Okay? You hit enter again. So what you're asking it to do is find a 0. It is trying to find out what 0 you're talking about. Where is this 0? And you're saying it's between these 2 points. And then it says, okay, you want me to guess? You want me to tell you where it is? Well, sure I do. And you see -4.5. Do that one more time. Second trace, 2. Then I'm going to go, I want to find the other one. I already found the one on the left. Now I want the one on the right. So I'm going to put my cursor on it. says left bound. So you hit the left arrow a couple times. You want to go to the left of it and hit enter. Now it says right bound. You want to go to the right of it. Doesn't matter how far. You don't have to go way past it. Just go past it and hit enter again. Enter one last time and it tells you the other 0. Fantastic tool. So use it if you can. Part D asks us for the maximum, and on this one I'm going to do a maximum or a minimum, extrema, the extreme values. There is no minimum. If you look at the range, you'll be able to tell where if you have a minimum or a maximum. The minimum would be over here, but it says negative infinity, which means there isn't one. It goes down forever, but it doesn't go up forever. It stops at 1. So that point, -4, 1, is a minimum, and more precisely, it is an absolute minimum, meaning this function absolutely never gets above that point. The other option would be that it would be a relative minimum, or a local minimum is another way you could say it, which means in this area, this is the highest it gets, but somewhere else, maybe the function goes up higher. But in this case, for this function, it never goes up higher. It's an absolute minimum. And let's do part E. In behavior, we look on the left side and the right side separately and see which directions they're going. I say directions because this arrow is going 2 directions. It's moving down, yes, but it's also moving to the left. It's kind of hard to see with this one maybe, but as it goes down, it also goes left. So X is approaching, that's the left portion. As you go left, your numbers get more and more negative. So X approaches negative infinity. And as you do that, where do your Y's go? Here's an option. Go look at your table. Okay, I'm at -28 in the X direction. What happens if I keep going in the negative direction? My Y values keep getting more and more negative. They're going in the negative direction forever too, even more quickly. What happens on the right side? Well, the X's are getting bigger and bigger that direction. They're going towards positive infinity. So they're going towards positive infinity. Okay, sorry, I had to jump to get to the positive numbers. So you see when X is 0, we're at -63. And then as you move in the positive X direction, what happens? These numbers start getting negative again. Oops. And they get more and more and more negative the further you go. They also are approaching negative infinity. As X goes to infinity, the Y values go down to the right and also down. 2 things are happening at a time. That's what they are. Okay, that's number 3. That was a lot of explanation. I'm also going to do number 5 in another video, and I'll show you how to find a minimum or maximum with your calculator as well.